Uh-huh.
So guys, today we will help you and we'll try to explain how to use this script, how to prepare for using it. We have a file with explanation, with help, how to use it, and it's on our Google Drive. Firstly, you need to download Anaconda, but Carlos already did it. He had it before. Yeah, and then we need to set up environment to use everything. So the next step is to install several of these approaches here. There is a Jupyter Lab, for example, or VS Code. It's free, and you could install. Could you scroll a bit down this screen? There is somebody need to be. Okay. There is no VS Code, but it could be. Yeah. So the next step, what we need to do, we need to open the Anaconda prompt or something like this. It needs to be the green one. Like
Okay, but should I start with Jupyter Lab then,
no,
or?
no, no, no. Firstly, we need to make an environment for this.
Uh-huh.
Yeah, it's called. Yeah, but this is another. This is another. Do you have a Jupyter or like Anaconda Navigator or not? Or sorry, Anaconda Prompt. It's called. I saw it in. Yeah, you have it. Prompt.
This one.
Yeah, yeah. Or PowerShell. It's not important. Yeah. So here, this is an environment already. Okay, open the map extraction. So we are missing these several steps, and you need step by step write conda create n map extraction Python blah blah blah. That corresponds to the map extraction here is the name of our environment. And the
Mm.
environment, this is like something that I'm explaining for everyone. The environment that is something contain only libraries that we need, that wouldn't overheat our machine, our RAM, etc. etc. So yeah, just copy paste and paste here. Yeah, and then
And I press enter
yeah,
line by line.
yeah. We will see what will happening because there is some processes. It would take some
Uh-huh.
time. Yeah, because maybe we could face problem. We need to wait a bit because it's collecting like these packages from the internet.
Mhm.
Mm, I mean, firstly, we're creating environment just like an empty one. Yeah, yeah. Here's the some packages that are required for classical Python work. Press Y, like yes, you are, and just press enter. Yeah, there is some installation of basic stuff. Yeah, and now we will see it a bit later. After that, everything will be finished. It will take some time, but we need to make it only one time.
Mhm.
hmm Yeah. So as you could see here, we're in a basic environment of Anaconda, etc., etc. So we created environment, and then we need to activate it. Yeah, even Anaconda prompt suggests you with this conda activate map extraction. This is that you already copied from the file, so you could just paste
Well,
it. Yeah,
now this one. Uh-huh.
yeah, it's the same. And this is uh, um it's strange because but possibly hmm. So in the how it's called this that we have here Menaye blah blah blah. I think this is like your environment, but maybe we are already in it. Okay, let's try to install
Uh-huh.
packages. Let's try to make the second yeah,
This one.
the third one, yeah. This is all our packages that we will need, and we
Uh-huh.
will install it inside our environment. We'll check. Maybe we will face with a problem, but it's a good way to show it.
Mhm.
Yeah, it will take some time.
Yeah.
Obviously, I could pause our recording. Let me. I will pause my recording and we will wait. Here will be
Okay.
the same procedure with possibly yes or no, Y or N.
Mhm.
But you need to press Y and it will install everything. Yeah. So guys, we are returned. So here we everything is passed. We did everything, and now I think we could Could you type here Jupyter Lab to run it? Just no. Yeah, just here, just in command line.
Yeah. How can you repeat?
Jupyter Lab or Jupyter Notebook. I mean, yeah,
All
but
together?
no. There is a space between the lab, between the Jupyter and lab, and Jupyter is typing not like this, not I but Y on the yeah here. Press enter. Okay, maybe it was my typo, but I think
It
no.
doesn't recognize.
Try to write it without a space between. Just press up on the yeah, and you could delete it. The previous comments. Yeah, press enter. Okay, we will see.
Still not recognizing it.
Yeah. Maybe this is because we are open this prompt not from Anaconda, not from Anaconda. Okay, close. Let's and go to Anaconda. Yeah, navigator. Yeah, and here you could see on the top the all application on base root. Press on base root. Yeah, and there is your new environment. Yeah, map extraction. It would take some time to activate it, but it's manual. And you don't. I mean, after the installation of this and making this environment, you just need to open Anaconda and change environment here without any like installation and other stuff. If you wouldn't face a problem. Yeah, here we need to find something that we will working with, for example, Jupyter Lab or Jupyter Notebook. Could you scroll down or something like this? Yeah, it could lag a bit. Yeah, and yeah, could you go down more? Maybe yeah, okay. Just use Jupyter Lab, install it. Yeah. It also wouldn't take much time, but still, just for like how it's called, the procedure of the logic.
Yeah.
To record everything. Okay, I will pause and we will wait a bit.
Okay.
So yeah, we installed Jupyter Lab and just press launch here in the Conda. Yeah, Conda could lag, but it's very powerful. Yeah, just press launch on it.
Launch here.
Yeah. It will open in case of Jupyter Lab or Jupyter Notebook in your browser. Then we need to find the file with my script.
Okay, from where do I look for it? From here?
You could press just plus and upload it from your yeah here. And no, sorry, it's another plus with the folder a bit right here. Yeah,
okay,
no, sorry, it's no, it's not. I'm sure. Okay,
this is the.
This is a creation in new folder. Sorry, my bad. Wait a sec. We will return to you guys.
Files,
Yeah. So there is a bit right here. This upload files stuff. My mistake. Yeah. And here on the list on the left, on the bottom, you will see. Just scroll it down a bit. You will see this file map extraction that's uploaded now. Just double click it. So here the script, and we need just step by step run every cells. So ignore this pip stuff because this is like if we wouldn't install the packages and creating environment, we could do it through the pip. But the pip have more problems with compatibility of different packages. So the best way to do it is to use conda, as we did, like conda create environment blah blah blah, conda install blah blah blah. Yeah. So and then we need two imports because we are already working in the how's called in the environment with uploaded libraries. We just need to import them in case of our code. So just put your cursor inside this cell and press Shift plus Enter.
Shift plus
Enter, yeah. Or you could press the play on the top of your screen. I mean,
This one?
yeah, and you could see that there is like the same approach. Okay, we face a problem. This is good. Go down a bit. No model has no attribute. Okay, this maybe corresponds to the numpy. So I could see there is a problem on the top that corresponds to the 8 line that corresponds to the import manager. Let's to not take a lot of time, go upper to the pips, upper, yeah, and just uncomment the line with people install manager, yeah, uncomment. To uncomment all the line, you need to press Ctrl plus slash.
Like having it like here and control slash the horizontal or the diagonal one?
Diagonal, the classical one, I don't know. Or you could just delete this, how it's called, the
Just
first,
normal delete.
or you could delete the first, no, not the line itself, but the first symbol. I don't know how it's called, sorry. Yeah, and just, so that means that this string, this line is commented now, and if we will run this cell, only this will be run on this string. So run this cell with the pip install. No, with the pip
Here.
install. Yeah. Unexpected incident. What? Could you delete space before the? Yeah. Try one more time. Yeah, it will take some time. It will install some packages. Okay, the requirements is already satisfied, so everything is okay. Try to run the cell one more time. Yeah, this one with the imports. Possibly we will face the same problem. Okay, dev testing. This corresponds to the environment, but it's important. We couldn't import. Okay, could you comment? Sorry. Let's show how to debug such approach. Could you comment the 8 line with the import manager to place the upper in the cell? This is an output. Yeah, and do you see there is like a import manager in the first block, the last one? Yeah, and you place this symbol between the line.
At the beginning, no?
Yeah, at the beginning. Yeah.
Okay, just need a second to
It's
find it in this keyboard because now I'm not sure
yeah.
because I never use. No, no. Here. Yeah.
Yeah, and run it one more time. We will understand is this corresponds to only mania problem. Go up a bit. Okay, yeah. So
Looks good.
this problem corresponds only to mania problem. So I think we will try to figure out what's happening because we need to fix it. And I will pause and we will return when we will understand what's happening, and I will explain what we will do. So guys, that problem that we faced, how you could fix it. You one more time opening the Anaconda prompt, and then you're typing conda update all. This is horizontal lines. This is called flags in case of the prompts, in case of the CMD and other stuff. And this gave us gave Conda task to update every packages. Carlos, could you go down please to just briefly show that there is like installation as it was before, and down, blah blah blah. We one more time press yes to install everything. Yeah, and for now it's okay. Then we're returning to the Anaconda, and from our environment, it's important to do it from our environment. Then we are restarting the script. To do such, we need to. Could you go to the kernel on the left top corner? Kernel, upper, right. For now.
Kernel.
Yeah,
Okay.
and then restart kernel. Yeah, press this. Yeah, restart. So this is kernel. This is like a core of our of Python that will run this script. And now we could be sure that everything is okay, because we tested with the kernels and everything is okay. Could you run imports one more time? Because after restarting kernel, we disrupting all the connection, and we are like turning off the Python in some way. And in case of this script, we could proceed, because as you could see, there is no errors, there is no warnings in case of the imports. Okay, and this is the functions that we have. These functions write it to upload it into working only with brain vision. We could adapt it easily in several minutes, but still just take it in mind that this is functions that was written to uploading files with VHDR extension that correspond to EG file, like the brain vision format of EG recording. And we need sequentially just run cells step by step from the top to the down. Okay? Okay. Run the cell with the function create nested file dict. Yeah. And in these square brackets, you could see that in the not run script, there is like an empty space, just a space. But if we will go upper to the start of the previous cell, Carlos, please, we will see that there is like a number. That means that this cell is executed. It is run, and if we don't see any errors under this cell and other stuff, that means that everything is okay. Okay? Okay, then we run the second cell. Yeah, and as you could see, everything is okay. This is the function that's upload and filtrate our data, and so here I could specify what we're doing, just for your understanding. So, as you could see here, yeah, I'm recording. As you could see here, we have a parameter that's called high cutoff. High cutoff, this is like a parameter when we execute particularly all the frequencies, yeah, that's above 15 Hz. And this is only one frequency filter that we have in this version. There was a notch filter before, but it's not a how it's called. It's not a good way to do such as we understood, but we could implement any filtration that we need. And also we have a parameter that's called order. This parameter corresponds to the specific butterworth filter. This is a specific mathematical filter that's worked with the signal, and it's specifically was not specifically, but it's very wide used in case of the EMG signal. In case of the EEG signal, they use different type of filters in general, not even like specification the butterworth or other one. Yeah, and then we're uploading everything. So yeah, here also I'm storing here the information about our sampling frequency, channel lists, in our case this is muscles, and some other technical stuff. Yeah, just run this cell. I just explained that, for example, if you will need for your reviewer that your high cutoff will be 5, for example, you just go here in a parameter high cutoff and change 15 to the 5. And that's all. And just rerun one more time this cell to implement these changes in the code. Yeah, and this is the function that this is just helpful functions that help us work with our data. Just run it. And yeah, and the next cell. This is the cell where we specified our parameters of and our naming of files, because this code could work with, for example, only with one file. It could work with all the files with VHDR extensions that you have on your PC. And based on that, we need to specify a folder. We will go on pause. We will find some files from Carlos, and then we will show you how to work with them. Okay? So we find the path, and we find the folder that contains this VHDR file, the MRK file, and EG file, as you could see. And for now, because the main point here that could be hard, yeah, but still, as you could see, the calling pattern of these files and the corresponding condition are the same across all the conditions. That means that before the first lower case. I forgot how it's called. This horizontal line, but on the lower part, yeah.
Like low dash or something
Yeah,
like this.
low dash, yeah. So before we have a subject name and after we have a condition. So to work this code, go to the please to the subject to folder, just in general that's contained all the data. Yeah, now we need to copy the path. Yeah, there is like this like a searching line or something like this with the passes in case of Windows. At least in MacBook it could be a bit different. In the new version of the Windows, you could just press on the folder right with the right button, and there will be like copy the path, something like this. I don't know, maybe Carlos didn't update, but it's not important. We need just to take the path, so copy this path.
Um,
Yeah, and put it inside the quotes. Yeah, here we need to be precise, because for example before the quote starts you could see there is a letter R. And this is important that here it will be, because if we wouldn't place it here, for example backslashes, the Python could have errors in case of the backslashes and other stuff. So be curious about this. So the next one, this is called a regex pattern, the specific type of working with the file names, and it's very convenient. It could look a bit messy, but we will understand how to look inside. So the first, as in my experiment, or in Carlos for example, as we saw sorry, we saw that the first part of the file name is our subject name, so this will correspond to the level 1, as we could see here. Yeah, so it will be the first line starting with the R here. Yeah, this is this line. And we could modify it based on our parameter. But for example, in case of Carlos don't have such levels of conditions. I mean, at least they are not specified in case of the file names, and this is important. So we need to comment everything that's not correspond to our to this structure of data file. So you need to put this these quotes. I'm not quotes, but these cells. I forgot. I'm sorry. Not asterisk. How it's called? Comment line. Yeah, but only on second and third line, because it's a bit different. This.
Second and third.
Yeah.
Oui.
And here. Yeah. Yeah, and for now we are ready to run everything. I mean, this is not we could delete these cells, but just for example, how to work with this. And for example, here you could have, so as an example, we have here 4 level of differentiation of our files that we could store, but it could be infinite number. It depends on our coding in case of when we're recording the files. Because in my case, for example, my file name looks like alt lowercase number of participant, lowercase sh, as you could see here on the level 2. On the level 3, lowercase one more time, number 5, lowercase v1. And this code will extract this data for our purposes. Yeah, and we could run it. You run it, no? No. Yeah, and we could see here that this could you there is like a yeah, could you extend a bit? Because here we have only a one participant, and you could see here that this code automatically specified the levels. The levels, this is like a markers. This is like a how it's called, like a columns in our data frame, in our future data frame. You could easily rename it when you will get Excel file, but still for your understanding. So level 1 is just our subject name. In case of our encoding, and in case of specified Carlos passes, we have subject 2. Level 2, in case of Carlos, this is a photo. And then inside this dictionary we have pass that corresponds to this specific subject with the photo condition. And you could see it's a pass with the say user Carlos blah blah blah. Yeah, with VHDR stuff. Yeah. Then just run the second cell. I mean the not the second. You got it. This is just
nested files.
yeah, this is just the same. It will give us. We could delete it. It will give us the same structure, just in other a bit way. We could delete it. And this function, the next one, that corresponds to uploading and to filtrating all the data. Okay, run it. Yeah, and there is like some outputs, and it will iteratively go through all these levels, and you will see the results in the final end. Yeah, and go scroll down a bit. Yeah, there is some warning, but in general, it's okay. There is no errors and other stuff. And just run the processed data, yeah, this one, and this will show us the new dictionary that contains the same level 1 participant name, level 2, in this case, this is a condition, pass, sampling frequency of our recording, channel list that corresponds to our montage and how we record it, and TMS event ID. This is like the marks that our MacVenture did automatically, and around it contains the data. Then we have data, and data is an array of vectors that correspond to our muscles, to other our stuff, that correspond to the voltages at every timestamps. And here we have an epochs already cutted around our TMS pulses. Then we have the same structure, but for the other condition post video. So also it have path, sampling frequency, blah 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 blah. So I mean the structure is equivalent in each levels. Okay, so yeah, then we are working with analysis. Here we just need to run these cells one more time. Just run it. Yeah, this is a function that estimate the peak-to-peak amplitude in desired in chosen by us. I will show you where to do it later a bit. In the time window, the maximum and minimum of the signal. Okay, run it. Yeah, this function that's return to us RMS and AUK of desired window. And this is important, and store some other different metrics. But we could manually choose what types of time window we want to choose. Okay, run it. And this function that's merge everything in together, and here we could specify our parameters. So here for my purposes I have 3 windows: pulse, pre, and rest. For pulse we are starting, this is a seconds as you could see, so we are starting to search the peak-to-peak amplitude in the time window from 10 milliseconds or from 0.01, this is at 10 milliseconds, till the 50 milliseconds, till the 60 milliseconds, because this is a duration. This is not the final stamp. Then for the pre-amplitude, for the pre-metrics, we are choosing start time minus 50 milliseconds till the end, accepted end, not including accepted. This is important because there is like an artifact of pulse itself at the end and at the 0 time of our epoch. And the rest, this is just in my case the resting state of my condition. Maybe in case of Carlos, I don't know, I didn't remember his paradigm, but for example, before the pulse, Carlos, before the pulse you have 1.5 seconds of like resting state.
I mean, I don't measure it, but I have some time that it varies depending on when I give the pulse. Yeah.
Yeah, but we could adjust just for example here, because I choose in my pipeline 1.5 seconds before the pulse. It's okay, it's enough. I mean, this is definitely a resting state. But for example, we could adjust it, exchange the minus 1.5 to the 1, just delete dot and 5 on the
Yeah.
rest window.
No, I mean, it's not necessary. There is time enough. There is
Yeah.
more than
Okay.
1.5, so it's
Okay.
okay.
Okay, but I mean, in general, you could adjust whatever you want. And the
Uh-huh.
important part here that for further analysis, possibly, I mean, you could just store this data and analyze it, but possibly the duration of these metrics for RMS and TAUC, the windows duration, time window, need to be the same. For example, to make a normalization or to
Mhm.
make another analysis. To just store, we could
Mhm.
just store these values without any thinking about it. But it's important if we want to go deeper inside of our analysis, we need to be sure that
Yeah.
the lengths are the same. And here, because we have sampling frequency 5000 hertz, that means that 50 milliseconds will transform to a 250 timestamps of our
Mhm.
voltages and times. Yeah, we are just multiplying them. Yeah, and here the function, you could just run it, that implements these approaches. I mean, it's yeah. Then we have here, what we have here, this is important. We have automatic rejection criteria and automatically applied in case of our data, in case of every map that we have. So, for example, if we will face that our peak-to-peak amplitude in case of, so this is the first if, yeah, this one, yeah. If we will see that the peak-to-peak amplitude is equal to 0, that's particularly impossible. That means that our signal is off, that our electrode is off,
Mhm.
and we will store this information. If the same for the pre-peak-to-peak information, also, if we have peak-to-peak amplitude, the third one, yeah, you're right, it's lower than 50 millivolts, microvolts, sorry. I'm always, yeah, microvolts, because I'm extracting the data in microvolts already. That
Mhm.
means that we will reject this trial, reject this epoch, reject this pulse, particularly this pulse, not all the pulses in one time, in one epoch, but only this pulse for one muscle. Yeah, and we will store that the amplitude low peak to peak map. If we will have, for example, the peak to peak amplitude is higher than 100, that's means the trial will be rejected because of the noise before the pulse, based on the
Mhm.
criteria the peak to peak high. And the third one, uh, if pre-RMS in the minus 50 milliseconds time window is higher than 10. 10. I thought that there is like a 6. Okay, if for example you don't need to some of these criteria, you just place this asterisk in lines before. Yeah, but you also need to comment lines all the block, all this block with the if here
So this
and this, yes, and this.
is like this, yeah?
Yes. Because it's like a lower part, and then Python will
Uh-huh.
say to you, what's happening here? Because the
Okay.
separation is important. Run this cell, and then we are storing this everything. Yeah, this is a function that's just storing all the data. This is like a technical functions. We could just write them, run them without any understanding. Yeah, because this is a run these two. Because this is just a function to store everything. And this one.
Mm-hmm.
Mm-hmm. And here we one more time we could determine our parameters because there this is just a household sorry hard there was like inside the function these parameters we have the same parameters but for example if you will delete these default window parameters here in this code it will take the parameters inside from the inside of the function. Okay, yeah, so
Mm-hmm.
run this cell. It would take some time, but and this one, yeah. Ah, I forgot to say one thing. Okay, run this cell too. Mm-hmm. And here we have our data frame. Go a bit upper to the previous one, to the previous cell. Yeah, a bit upper. Yeah. So here we have the specific part of the code that's called result.def blah blah blah. And one of the parameter is output path. In our case, this is output file, okay? But this is for the further machine learning data storing. Sorry, I forgot about this. And if we will go inside the folder of Carlos data, I mean that we specified inside this path, could you open it, please, Carlos? Yeah, here we just stored this data frame, this table that's will be printed below, sorry, but in a specific format, and we could open it. So this is just for storing the data without like any modification, etc., etc. Sorry. And if you don't want to save it, return please to the to Peter. Yeah, put after the equal, not output file, but none. Yeah,
Output file
yeah,
here.
here just put none. With a high
Okay.
letter N, first one.
But no needed to do it now, no? Just
Yes,
to
yes.
explain.
No, just to understand that you will be
Okay.
understand because these files could wait a lot,
Yeah.
because they contain all
Okay.
the raw data. Okay, let's
Yeah.
go downside and look on our data frame. So this is and could you extend it a bit, please? So this is our data frame. And you could see, you could scroll it because it's contained 28 columns. They are technical in general, but it's important for next step of plotting. Yeah, as you could see, let's go from the start. I will explain what's happening here. So we have an epoch. That means that when we gave a pulse, we have several maps from different muscles. And we could see here that, could you go upper a bit, Carlos? And put pedesage option displayed the second line. Put here not 5, but 10.
10?
10, yeah. This is the maximum numbers of the rows that you enter around this cell. Yeah, and we will see more rows. Yeah, just don't scroll it down. Yeah. So here you could see that for one pulse, the epoch number 1, we have two muscles, FDI right and ADM right. Okay. Also, what we could see here in the other column, we see auto reject. That's false means that the map is good, but the auto reject true means that we have some reason to reject this pulse, this map itself. And in this case, we are stored that we have low peak-to-peak map. So that means that map itself has 35 millivolts from the peak to peak. Yeah. Also, I'm here storing the data vector and time vector. This is our voltages and times. This is important for machine learning possibly, and for the plotting, for further plotting, because we will save all the plots. Level 1, as you could see here, as it was before in our dictionaries, this is our subject code. Level 2 is our condition. The second, yeah, it's okay. Then we are storing sampling frequency because it's important in general for analysis. For example, it could be important for filtration or for calculation of specific boundaries, because this is like one of the important part. Then we're storing here. Could you scroll down and scroll to the right? Then, because there is scrolling only there. Yeah. Thank you. Then we have peak-to-peak amplitudes that correspond to this specific map. And also, I'm storing the peak val and throw val. That means that's the maximum and minimum of our maps. And the indexes. Indexes in this case, that means we have timestamps, and we just count the number when this peak or throw appeared. And some other metric, pulse RMS and pulse AUK. This is RMS and AUK in 50 millisecond window from the 10 milliseconds till the 60 milliseconds around our pulse. That's the reason why it's called pulse RMS. And I wouldn't go in technical details how they calculate it. You could just Google root mean square and area under curve. But in general, it's important to store them, possibly. Then we have pulse info with the information of our starting window, of our window when we are looking for. So this will be, as you could see here, 0.01, 10 milliseconds, and in our case it's particularly 0.06. In number of samples here will be, as I said, 250. Yeah, so, and this is important just for comparing in the future analysis possibly. Then we have information about pre-peak to peak, and here we have 21 in this case, and the same information as we have for peak to peak map itself, but for the pre-peak to peak. Could you scroll a bit right, sir, please?
Mm-hmm. Mm-hmm.
Mm-hmm. Yeah, this is the final step. Yeah, and then we have information about pre-RMS as the same time window, minus 50 milliseconds till the 0, except 0, pre-RMS and pre-AUK in these time windows. And then resting RMS and resting AUK at the same length of the window, but from the minus 1.5 seconds before the pulse. Okay? So yeah, and now we have this data frame, but it's particularly give us nothing. I mean, in case of our type of analysis. Let's proceed. I mean, you could not even look inside of it in general. It's just like my explanation. So now we need to show to save our Excel file, and we need to save our pictures. You need to have some empty space. For example, for 18,000 of rows, I reserve 1 gigabytes of memory, of SSD memory, not RAM, but like hard drive memory to just store these pictures. Okay, and we need just to run these functions step by step. This is the first one. Yeah, I think this is a problem of Jupyter Notebook. Sometimes
Okay.
happens. Yeah. Yeah.
Should I run this one
Yeah.
already?
Yeah. Yes. It's they already run, and this is the function that will store. Okay, we face. Okay. Here we face a problem, and this is a good example. And we will fix with you this problem because you are looking in the bottom part of the error, and there is group column not found level 4 because we didn't have such level in our data frame. Because this is, we need to know the data frame structure to specify how to group our data. Go upper a bit at this here, yeah, and here you could see we have a group calls that consist of level 1, level 2, level 4, and epoch. But in our case, we don't have level 4. We could have it in case of like other approach, but you need just to delete it. Yeah, with the comma, yeah, like this. Yeah, and delete for just, yeah, perfect. Run this cell one more time. And there is no any error, and we need to wait. Could you open the folder with your files, please?
Yep.
Yeah, here you could see that there is another dictionary folder with epoch plots, and it's automatically, you could see in real time how it's generated the pictures of all the maps correspond to one pulse of your data. Could you open one of them, please? Yeah. So we could specify DPI, for example, if you don't good with the quality of the picture. But in general, what we could see here, as I said, we are storing the data about pre-peak-to-peak, pre-pulse information, and this is a green window. Yeah, minus 50 milliseconds before. And we are storing information, searching the maximum and minimum in the purple one with the pulse info on the infographic. Yeah, this is 50 milliseconds too. And on the left top corner of every plot, you see the peak-to-peak values, pulse RMS, and pulse AUK, and that correspond to the purple window, pre-peak-to-peak, pre-RMS, and pre-AUK, that correspond to the green value, and rest RMS. But for our purposes, it's not so important to see what's happening in case of the resting state, because I mean, in this case, it was like minus 1.5 seconds before, and if we will plot it, not separately but on the same graph, we wouldn't see anything correspond to our region of interest. Yeah, just because of scaling. Yeah, and yeah, and for this and the script will store in based on your path that you specified at the every start at the start. He will store and create this folder and store all of these maps. Could you return to the folder, please? And go to the subject too. hmm Yeah, we need. Could you reload the update the folder like this rounding left and right and
Good.
just refresh the page.
Here. Okay.
Yeah. Sorry for my bad English. Okay, we need to
No, I
wait.
didn't knew it could be done,
Yeah.
actually.
Could you open the Jupyter lab? So here, could you? Yeah. So this is very time-consuming procedure to store every maps. In case of my PC, it took for all of my data to uh, like 40 minutes to store all of these pictures. And but this will like take the gigabytes of your memory. But in this case, we could look inside because we still don't have Excel table, but we will have it inside after the codes will finish. Could you go upper a bit to the cell that you just run? We could see here with this asterisk, with this like star inside this square bracket, that code is still running. I think we will pause the recording and we will return to you when it will be finished. So I just will add one more thing. This is a master script. In general, you don't need to run it every time because you could specify just the folder with all folders of your participants, etc., and it will be automatically calculate everything. If everything correct with regex, if I mean on the first step, that was like the hardest one. Okay, we will pause and then we will return to you and we'll show how the data in our Excel file will look like. So we finished. It didn't take so much time, but it's still consuming in case of memory. But I think if you have 16 gigabytes of RAM, it will be okay. So could you go to the? I mean, I think it will work, but it will work slower with 8 gigas, with 4 gigas too, but it's not the case. Could you go to the folder, please, with the files? Yeah, and there is after the script will finish his work, he will store everything in this Excel file. Yeah, could you open, please? It. So I'm deleting everything that we don't need, like the vectors of the voltages and other stuff. But here we have the same structure. We have the level 1, level 2, peak-to-peak amplitude, pulse RMS, pulse AUG, blah 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 blah. So yeah, and for now everything is good. You have additional E column, the fourth one, or the no column on the top. Yeah, that's called manual annotation. E1. Could you show it, please? No. On the just on the Excel, a bit righter. More.
But A1,
E
then
E column. Yeah, this one.
okay, E1. Okay, my
Yeah,
bad.
yeah. Sorry, my English is bad.
No,
uh,
no.
what? So here the place um, for your annotation, for your writing down. What we could do, how we could work for now. We don't need to run the script one more time in this case. We now, for example, you're opening the pictures that you have. Carlos, could you open it? Yeah, epoch plots. And you are starting from the scratch, for example. Yeah, and you could switch between the between the how it's called, yeah, windows with Alt Tab, for example, as Carlos did. Yeah, and you could press here right. There is like or right button, yeah, and you could switch the pictures like manually, very easily, without any like memory consumption. Everything will work okay. And here you could specify what's bad. For example, if my script didn't detect that the map is bad, you need to write down something in case of manual annotation. Yeah, but for example, if we will look on the first, go to the left to the start. To the to the epoch 1. This is epoch 2. As you could see on the photo, on the top there is like all the information about Winnie. So this is subject 2, level 2 in our case photo, and epoch number 1. That corresponds to every information. And we could see that definitely the IDM write pulse will be rejected because the peak-to-peak amplitude is low in this case. And you could cross it like this. Okay, so this is in general all, but we have additional small part of our of my code. Could you return to Jupyter, please? Could you restart kernel, please? On that
That
lower,
was
yeah. Restart.
here.
Yeah. Restarting kernel means that, but we don't have anything run before, and that's mean for example, if you want to look precisely in a manual way on our maps, we could need to look inside of it. For this, we need to firstly store this file with results data h5 that Carlos stored. Could you show it, Carlos, in the folder? Yeah. So it's in results def h5. This is a specific extension of our data frame that we stored. And we need to, for example, if you are messing with different files, you could specify here the path. One more time. Could you copy path one more time of the folder with subject? Yeah.
From here?
Yeah, from here. Just for example, because you could play with it in general. And let's go to the Jupyter Lab one more time. So we don't run. Let's imagine that we just opened this script and we didn't run everything before. So what we need to do? We need to do imports. Could you go lower, please? Yeah, we need to go to do some more imports, and this could be important because matplotlib, this is a package that plots for us graphs. It could have some problems with other packages. So the best way to do so is restart the kernel and then run this part of the code separately. It's only several functions, but it will help us to plot everything in a way I will show you. Could you run the imports, please? Yeah. This one, the next one, it will search. Oh, we faced the problem. Matplotlib, could you go lower a bit? What's happening here? To the end of the error. Okay. Okay. Could you go upper? This is corresponds to the Matplotlib backend. Could you exchange Matplotlib widgets with the word widget? The word widget.
Where is it?
Upper. And lower the final line of this cell. Yeah. With exchange it with q t 5 3 5. Yeah, run it one more time. No, still okay. Exchange qt5 to the notebook. This is just another backends. Maybe it wouldn't work. Yeah,
like this.
Yeah, like this. Maybe is this. Okay. That means that we need to work with. If you will face such problem, that means that you need to work with your environments and dig in why it's happening. But I hope it wouldn't happen with you. So just put except the notebook inline in one word, inline. Yeah, like this. Run like this. Yeah, and for now it's okay because the matplotlib is but curse word. Sorry, but it wouldn't work interactively in this case because the inline is not about interaction with the plots in general. But here need to be like a widget or notebook or Qt5, and it will give us the plot with the possibility to interact with them. But let's show how it's worked still. It's not so much time will take. Okay, run the next cells, please. And another one. And another one. Hope it will work. Yeah, and here, for example, you need to specify that path that we copy with your h5 file. Yeah, and be curious about this, because also you don't need to lose the R before the string, and the quotes need to be opened and finished and closed. Yeah, I mean, this is important. And just run the cell. This will take some time, but not so much. It will just upload it, our data frame that we stored before. And here we have our, for example, we have a criteria. You could delete, or you could just run this cell. Yeah, and this is that data frame that we stored, just for our purposes. It's easier to look like this. Then this is empty row. Sorry, this is a garbage a bit in this case. Yeah, and here we have a criterias. Criterias, the plot of the epoch that we want to choose. That we want, for example, we want to look on the first epoch on the specific channel that we know, and the specific participant. In our case, this is level 1, and level 2 it will be photo. Carlos, could you write down inside these quotes after the I mean, like replace MMBR with your uh, muscle. No, this is a channel. This need to be muscle.
As they appear.
As they was in your data frame. You could open Excel because it's the name is the same.
FDI to right.
Level 1, it's our participant name. So, for example, you want for subject 2. As I mean, it's important that there is no typos here. Sub 2, yeah.
Wait.
Yeah, and we don't have level 3, so you could comment or delete it in general if you want the.
Level 3.
Yeah, and the level 2 in our case, for example, let it be like photo, video, but be curious that this is a strings, and the lower and uppercase is important. So yeah, yeah, and run it. Yeah. So in our case, because we faced with the problem with these matplotlib backends, but in general here, if you wouldn't face with such problem, you will see the interactive graph with these plots. With this, for example, if you want to check does the script calculate maximum and minimum correctly, you will be use your mouse to just place somebody here, and on the bottom of your graph there will be a coordinates of x and y, and you could like manually check it, for example, or something like this. Yes.
Okay. And then if, for example, this will show me just for photo. If I wanted to continue with subject to that video, I would have to change here and run again.
Yeah, but
okay.
you have all the photos. This is for more, and you have all the plots already stored. But I mean, it's for if you are not convenient in something, or do you want to check something manually. I mean, because it's impossible to plot interactively in case of Python all the plots. I mean, I faced with a lot of technical problems with this. So I decided to do like this, that we could interrupt our script, that we don't need to run our script every time, just to store one time and then use it.
For something specific.
Yeah. For example, if you stored the previous month, year, these files with extension x5, h5, sorry, you could just open it, find the proper the place where you stopped before, and then restart it from this place. You don't even need Python. This is just for example that we could do it like in a manual way. Yeah. So I think that's all. guys. If you have questions, write to us. I will upload this video to our Telegram chat, and I will attach the link to help and a link to, not a link but file with the Python script. Yeah, so feel free to write to us. Yeah. Bye.
This tab is for something else, or is all?
No, it's just we could delete it. This is just a print of
Ah,
our yeah. So we could delete it. I will fix some
yeah.
garbage
No,
because
perfect. No, just wanted to ask you. Perfect. Thank you very much.
yeah.